This is Fragmented, an Android developer podcast where we talk about building good software and becoming better Android developers. I'm Donn Felker.
And I'm Kaushik Gopal.
Welcome to episode number 11. So Kaushik, it's been quite a while since we've done an episode with just the host, and I think today's the day.
Mm-hmm.
But before we get started, is there anything going on with you that's new at all, or what have you been up to?
My life has been completely normal, Don, and I'm thankful for that. So it's nothing beyond the ordinary, but I have been doing some cool stuff. So I've been obviously working on the topic that never seems to escape me, which is RxJava.
Yes.
And recently in the GitHub repository where I host a couple of samples, I wrote some code for like the exponential backing off strategy.
Oh.
Yeah, that was pretty interesting. It was nice. Mike Evans essentially asked me. I had this idea from a talk I gave previously, but I've just been putting it off. And yeah, I decided 4th of July, it was a good time as any. And I flushed that example out.
So what does that do?
So basically, exponential backoff is a strategy where you sort of, based on feedback from the result that you get, you try to adapt the way you do. So a very typical example is if you try to make a network call and retrofit comes back with like an exception saying, hey, your network is down or something, then you don't want to try repeatedly after like every 5 seconds. You want to try 5 seconds, you don't hear back from your server, then you want to try 10 seconds after that. If you don't hear back, then you want to increase it to like 20 seconds. And then you keep sort of like increasing that interval up to a certain point at which you give up and say, hey, I've tried 50 times. The server is not getting back at this point. You should probably give up. So you can do that relatively easy with RxJava. If you try to do this manually by hand, it's possible, but it's pretty complicated. RxJava makes that pretty simple. So that was a nice example to sort of like flush out.
I can attest to that. I've written that code by hand, and it's definitely complicated.
Yeah, it's
error prone too.
Oh yeah, for sure. And yeah, testing it isn't very easy either.
No, not at all.
Another thing I've actually been doing is I've been experimenting with RxJs, which is basically the sister equivalent in the JavaScript framework. So I've been trying to write the same examples in RxJs, just because one advantage I've found with RxJs is it's so easy to get it up and running because it's just like a browser, right?
Mm-hmm.
So I've been writing examples in RxJS because for those who don't know, the reactive sort of like extensions framework is very similar across platforms. So in RxJS, it's almost like the same that you would write in RxJava, the obvious syntax side.
I've been doing a lot of Node development since Node 0.4.
Oh wow!
And yeah, I've been doing it for quite a while.
You're an early bird at most technologies, aren't you?
No, only a couple of them. I fell into Android on accident, and I fell into Node because I was just really interested in the new tech at the time. But anyway, I saw that the RxJS came out, and I've really been wanting to get into it. So that's really encouraging to hear that makes it simplified or makes it easier to get up and running.
Oh yeah. And RxJS is also a very nice framework. So I've been doing a lot of that.
That's cool.
What's up your side?
A lot of stuff. Not too much technical stuff. One big thing I guess I'll announce here is that I am moving to the East Coast.
What?
Yep. Moving over to the good old state of New Jersey. So if you are in New Jersey, New York, or East Coast area, we'll be moving over there in the middle of August, and I would love to connect with you guys. And I've talked to a few people over there to let some people know, but that's kind of the plan. And a lot of stuff regarding that. Moving is not really a simple task by any stretch of the imagination.
Oh boy, yeah.
Especially with kids and wife and dogs and cats, and move the whole Felker farm over there.
Wow, are you doing like a road trip?
We are actually. We're so we hired movers, of course. It's just house is too big to do by myself and like a big U-Haul. And then what we decided to do is completely go the entire National Lampoon's Vacation style. So we rented an RV from like a RV rental place, and we are going to taking all the dogs and cats and kids, and we're just kind of RVing it over for about a week across the country. So we'll see how that goes. That'll be a fun time.
That sounds exciting.
And other than that, the one other thing did happen. Google contacted me and awarded me I don't know if it'd be awarded or what it would be, but it's I am now a Android GDE is what it's called, Google Development Expert. So that's pretty cool. I'm excited about that, to be part of that prestigious crowd now.
Congratulations. I know like a couple of GDs that I met in IO, and yeah, that is a very elite and prestigious class for sure. Like some of the developers there are like super good. So yeah, excellent.
Yeah, very excited, very excited. So, but that's all that's happened with me. So, but enough early banter here for us. What are we going to talk about today?
All right, so before we begin this episode, there are a couple of quick things we want to touch upon. There's some follow-up for this episode. Michael Panzer, one of our listeners, who's always been an active listener and giving us great feedback, mentioned from the last episode, which we had with Michael Bailey, he pointed out that the ART compiler basically has a moving garbage collector, but that effect is only seen in the background. And he mentioned that over Twitter, and he provided some references, which we'll definitely add in the show notes. So I just wanted to add that bit of follow-up from the last episode.
And one other thing we want to mention to the listeners is we're going to be doing a little bit of housekeeping here at Fragmented Podcast. We're moving our podcasting hosting providers, not our website hosting, but our podcasting hosting providers, which means we'll be moving the RSS feed associated with that. We will let you know when that does take effect. Hopefully, everything we do on the back end will automatically have your podcast players and catchers move over to the proper host, but we'll also post a blog post about that when that does happen.
Absolutely. So recently there's been like a deluge of blog posts, and many people have been like on Twitter and Reddit sort of asking about this whole clean architecture thing, like view models, presentation models, presenters, model states, clean architecture, MVP, MVVP. Like there's a whole bunch of posts and a bunch of blog posts, Reddit threads going, and on Twitter people have been asking. This has also been a very heavily requested topic for the Fragmented podcast right from the beginning. And so today seems to be the day where we're going to talk about this. We're going to approach it a little differently just because I know I've talked with you about this like offline, and essentially we have sort of strong opinions about it, but we also strongly believe that there isn't necessarily a silver bullet architecture right out there at the moment. So we're going to try something a little different with this episode, and yeah, let's see how it goes. Definitely.
I think it's a great idea. I know that, Joe, was it just earlier this week we were talking on Slack regarding some, this clean architecture stuff that we both are pretty passionate about and how to implement it best. And that's the one thing that's kind of come across every single time is there is no golden ticket. There's no one way to do it. There's a lot of different ways to do it, and it kind of depends on what you're doing. Android is a pretty bare bones, your bare bones architecture when it comes down to it. If you were early on with Android, you knew that you basically got a label for a title bar, and that was it, and a black screen. It's nothing like the web development world where you have tools like Rails or Express.js if you're a Node, or other languages like Django and Python and so forth. Those kind of things, some libraries and frameworks do kind of exist out there, but it's still very early on at this point.
So yeah, let's talk about what the agenda is for this episode. Essentially, what we're going to be doing is dividing this into sort of three parts. The first is we're actually going to be talking about the goals of such an architecture. So if you did come up with an architecture, what's the point? I mean, why are we even like subjecting ourselves to this? What the Android operating system gives us, is that not sufficient? What are the problems with that approach? And why would we even like try to like go out of the way to come up with this clean architecture? So we're going to focus a lot on like the goals of this architecture. We're also then going to talk about the definitions and the terms. Some time back on Twitter, I sort of like sent this tweet where I said like the first step towards this clean architecture is basically cleaning up all those names, because there are like a bunch of names like this: view models, MVP, MVVP. So we're going to try to sort of come up with terms and sort of key patterns that'll help us understand clearly how we can sort of like demarcate the boundaries between the responsibilities of each of these objects. And there are a bunch of like new and nice solutions that at times can seem pretty confusing, just because even like the terminology is like tricky. So we're going to talk about the definitions and the terminologies and sort of like understanding that as the second part of this episode.
And finally, we're going to wrap the episode up with some really good references that we feel that that you, the listeners, would really benefit from. And some of these references are directly from the bookmarks of myself and Kaushik. If you were to look on the bookshelf that I have here at my house, you would see some of the books that we're going to talk about later in this episode. And the links are now online, of course, because everything is digital, but you can still get the book form, and it's a lot of times it's nice to just have these things sitting on your shelf so you know that it's in there. You pull it down and you can take a look at it. But we'll be talking about those references. But in regards to the episode overall, those are the three main highlights. But what we're going to be spending the majority of our time on this episode is the first two parts of the episode, and that's understanding the goals and clearing up the definitions and terminology that's out there. We think it's fundamental to understand those names and so forth, because without those names and so forth, we can't start evolving our own architecture. A lot of the people on teams need to share the same terms, and that's kind of what one of the big things with having common terms solves. Is if I sit down with another engineer and we're having a common problem, I can say, hey, look, I'm thinking about using a service layer here, or hey, I'm going to use a passive excuse me, I'm using a supervising controller here. Immediately, if that engineer is familiar with that pattern or that practice or that definition, they're going to know what I'm talking about, and we don't have to spend another 10 minutes of ceremony to discuss exactly what this architecture is. So, and again, we're just going to reiterate this probably many times in this episode. There is no bulletproof architecture, and so it's important to understand each one of these pieces correctly. And one of the other things I think it's important to note is that even though that these are patterns that are out there, a lot of people will suffer from. There's a proper term for it. I forget what it is. Kaushik, let me know if you remember. It's a term when someone reads like the pattern book and they apply the pattern to everything.
Cargo culting?
Yeah, maybe that's what it is. I'm not sure.
Okay.
Yeah, but you basically read the book or hear this episode or something like that, and then everything all of a sudden has this pattern on it, and you just apply it to everything. So it's you probably shouldn't be doing that, but also make sure where all the pieces fit together. That's kind of one of the core goals that we're having here. So that's going to be kind of the goal for the episode. Now, if you guys, the listeners, really want some deep dives in some of this hand-picked information that we provide in this episode, please let us know. We really need you to let us know. Send us a tweet at FragmentedCast or hit up at Donn Felker or at Kaushik Gopal on Twitter. Just hit us up any one of those ways. We monitor all those accounts, and we'd love to know if you guys would like this in more detail so we can actually put out another episode kind of getting into some really deep stuff.
All right, so let's talk about the very first goal for this architecture. Now, a common problem that always comes up is that our activities and our fragments become these super huge, massive, gigantic objects which do a whole bunch of stuff. We shouldn't let our activities become what is commonly known in the developer parlance as God objects. Now, God objects are basically this single object that do everything related to your application. This is commonly a bad pattern because essentially what happens is if you want to tease out functionality or you want to change functionality within the within your class, it becomes really difficult because you have 5,000 lines of code in your activity and you have to scroll all the way up or scroll all the way down. And then if you want to change a certain part of functionality, given that it's within this God object, changing it becomes very difficult. So people usually want to avoid creating super huge God objects and letting their activities and their fragments become these God objects. But it's important to understand that the whole point of having these presenters and view models is not to merely abstract for the sake of abstraction. So people sort of have this tendency of saying, oh, I need my activities and my fragments to be smaller. I shouldn't have so much logic. It shouldn't be a God object. And what they do is essentially just pluck all that functionality out and plant it into this presenter or view model object. And then what lands up happening is your view model or your presenter becomes this super huge God object. That's really not helping. And the reason I want to bring this up is because one of the goals of this clean architecture is not to simply create smaller classes. It has to have a good reason. You have to have good reasons to sort of tease these objects out into independent sort of service objects that have very clear and precise functionality. So it's important to understand that if you simply move all your logic from your activities and your fragments into the presenters, it sort of defeats the whole purpose of having this clean architecture. It really isn't any clean. So That's one important point. We shouldn't abstract for the sake of abstraction, because another big problem is having multiple layers of abstraction actually confuses the hell out of other people. So if you have someone who's code reviewing, or you have another developer in your organization that comes and sees your code, she's probably going to say, oh my God, this is crazy talk. You shouldn't be writing code like this. You have to have better approaches towards coding. So what's another goal, Donn?
One of the other big goals is something that I've been kind of, I don't know if you would say passionately happy or passionately angry about, I'm not sure. But it's painless UI testing. It's kind of an oxymoron to use the word painless UI testing in Android right now. Mm-hmm. It is what it is, right? So here's the deal. Many people find that when you want to test a GUI, it can be pretty tough. And in Android, it seems nearly impossible because the GUI in Android is very tightly coupled to the Android framework. Mm-hmm. And a lot of times we don't have control over the framework. And the prime example of this is we can't use the constructors and activities or fragments, which, if you notice, if you're using like a dependency injection framework like Dagger or RoboJuice or something like that, we're doing field injection. We're not doing constructor injection, which is considered the industry standard for other languages such as, typical server-side Java or .NET or other languages and so forth. When the UI is tightly coupled to basically the underlying framework, it makes it very difficult to tear these apart and test them. And so a lot of times what you'll need to do is fire up an existing framework to test it. And a lot of times what you end up testing is actually the full stack. Did you set up your emulator correctly? Did you set up the correct version of Android? Oops, I forgot to install this, the GPS module I needed, or something crazy off the wall that you forgot to do. And it's very difficult to test. So we really want to try to get it to a point where we are actually testing what we see, and not what we see as developers, but also what the user sees, because that's what's most important. Because for me right now, for example, I'm building applications for Point, and they are building them for customer-facing and merchant-facing applications. And a lot of times I'll actually need to think about how the merchant or how the customer is going to interact with them. And so I need to make sure I'm writing tests continually over and over, that I can execute these quickly and painless. Again, painless is not really an option right now in Android, but we do need to test. I can't tell you how many times this week alone I've dealt with some regression issues. And there's multiple reasons for that. It's just we don't have a lot of time to do the testing. The testing does take extra time. But as we're running into more and more of these situations, we are having to take the time to write the existing, either be it UI automator tests or Espresso tests. And the long story short is that we just need the tests. Now, the big thing is, the UI reflects the state of the system, which we have control of, and so that's very important. And so what does that mean? It means, was this button clicked, and when we stepped on this button or pressed on the button and we filled in this text box information, did the application do what we expected it to do? Did the form filling process execute the way we expected it to? Is there errors occurring, and so forth? You have knowledge of all this information in your application. You're the one that built it. You know how it should work. Now, one of the tough things about painless UI testing, though, is as developers, we are very optimistic by nature. We automatically assume the best case scenario, and so we always test the happy path. And it's working, and we think, great, now I'm going to move on to the next problem. And then we always have the best intention to go back and clean stuff up inside of our test. If you doubt me, go inside of your IDE and search for all your to-dos. I guarantee you have a ton of them somewhere. Oh boy, yeah. We're all guilty of it, right? And so... Mm-hmm. So the big thing is you know the state of your application, but you also need to understand the state in which you don't expect it to be in, and test that, because you'll find some really odd edge cases. So one of the other things with making UI painless, UI testing painless, and utilizing view models and controllers and all these different patterns is currently we have to leave our state inside of these Android widgets or the activities or the fragments, and it just makes it harder to access the testing. So when we extract these things out into presenters and view models and these various different patterns, it kind of removes and separates and pulls the Android framework completely out of it, which makes it a lot easier to test. And so the big point is we just want to get away from the framework, because the framework introduces a lot of pain in testing. And Kaushik, I know that you love to talk about this topic, and I'd love to hear a little bit what you think about it.
When people say UI testing, you have to understand what UI testing entails. You don't really want to test if your text view works, because Google already does that. When they release the Android APIs, they probably do a much better job than you and I can ever probably do to test if a text view works under various conditions. So it's sort of important to understand. People always think that when it comes to UI testing, you want to test like, oh, if I set this text view with this text in my activity, does the text show up there? If I change the text, does this happen? That's really not what you want to be testing. What you want to be testing is how you control the UI. You made an excellent point previously, Donn, and you said that state is basically what we have in control. So the only things that you really want to test with regards to UI are the things that you expect to happen differently. If you do condition A, B, and C, if you want your text view to show a certain text, then you want to test that fact. You don't want to test that the text view is capable of just, many a time people come with the good intention of saying, oh, I need to add more tests. I need my application to be more thoroughly tested. But they sort of like sway in this incorrect direction where they're trying to test the wrong things. And that's part of also what makes testing so difficult, is that understanding what you really need to test. There are some parts of my application which I'm completely comfortable not testing at all. And that's because I'm not really swaying from the ordinary too much. So at that point, I don't really feel like a sort of need to test. But if it's something that's key, like for example, if the user has like a certain flow that they're using in my application and they expect something that's very important to be seen because they can't proceed to the next screen, or they won't really understand what's happening without sort of getting that visual cue, and that visual cue is extremely important for my flow, then that's definitely something that I want to be test. So people have to understand clearly when you need to test something and when you don't need to test something, and the value of actually testing something.
I completely agree. We had this very similar conversation earlier this week in regards to kind of just some basic flow testing, like you had mentioned a second ago. How do I make sure that, a lot of times maybe I'm going to have 10 fragments that are managed by one activity, but depending upon what actions happen, the user may need to go from fragment A to fragment B to fragment C, but the next user may need to go from fragment A to D, then to B, then to E. And how do I test that? And using a controller pattern or something like that, or to be able to test this little routing logic that you have and make sure that you have it right and test it very quickly without having the Android dependency is huge. And I actually ended up writing some stuff like that this week, and it made my life so much easier. I could hit run, the tests were done in a few seconds. I didn't have to wait 2 minutes for this whole UI automation to kick up, and it was just great.
Absolutely. Another goal of this clean architecture is to be able to avoid framework dependency as much as possible. The reason you want to be able to do this is, again, one, it makes testing easy. But what are some of the techniques that you would use? Some of the techniques that make it easier to be able to sort of avoid the framework is essentially using POJOs, plain old Java objects. If I have any Android-specific dependencies in these objects, like in any of the objects that we're going to talk about, like the view model objects, the presenters, the controllers, then that's always a sort of red flag for me, because as much as possible, I want to avoid framework dependency. And the reason I want to do that is because it makes testing much easier, because then I don't have to worry about framework-related dependencies and the whole bunch of quirks that comes with it. For example, if it's a Samsung device, if it's another normal Nexus device, if it's an emulator, I don't really want to be worrying about such things. And the foolproof way for me to be able to do that is to basically just shove all that logic into POJOs, which is just plain old Java objects. Then I can drop to a much simpler state and perform almost like unit testing at that level. So I guess we've covered at this point like what our goals are. Like if we were to sort of like implement this clean architecture, like what our primary goals would be for this architecture. At this point, I think it makes sense to sort of like step in and talk about some of like the definitions and the terms that we'd like to maybe come up with. I want to like sort of start this whole discussion of the definition and the terminologies basically by saying a lot of these terms that we have sort of picked up are from Martin Fowler. And Martin Fowler is this person who has like amazing clarity in coming up with these definitions and these good terms. And we're going to point to a couple of his articles. Donn, when I was talking to you offline, you also mentioned this, and I completely agree. This is the content that he's written in these articles is extremely dense. If you go through this whole thing in one pass, you're probably not going to like immediately understand what he says that easily. You'll have to probably take a run at it more than once. Also, Donn and I have sort of like understood this pattern pretty well at this point because we have actually tried to implement this pattern. We've actually hit the roadblocks, and having hit these roadblocks, we've sort of like understood, oh, so that's why he mentioned that sort of like point, or that's the meaning of this, that's the nuance in the meaning of what he was sort of saying. So Donn, if I remember correctly, there are like 4 articles that were sort of like seminal essays. What are the 4 articles? Could you tell our listeners about it?
Yeah, the first one is about, well, I kind of list them in different orders depending upon what I'm talking about. And with Android, what I'm usually talking about a lot of times is either a presenter pattern or a controller type pattern. And so the first one I usually like to point to is written back in 2006, and it's like you said, these are very dense and they still hold true to today. I had just tweeted maybe about a month ago where I said that Android is now in 2015 approaching where other languages had approached in the mid 2000s. And the first article that I like to talk about is just supervising controller. And supervising controller is where we factor the UI into a view and into a controller. So there's 2 different components, and where the view handles the simple mapping of the model. So we have the model like an object, and the controller handles the input response to the view logic. And so when certain interactions are happening, that's what happens. So that's the supervising controller. The next one that we have is that I like to talk about is the presentation model. Now, the presentation model, it helps you represent the state and the behavior and how they independently work with inside the GUI. So meaning, again, inside the Android UI system itself, and how you can interact with them. And again, I'm just scrolling through the articles right now, and I'm doing very long scrolls on my trackpad. And some of these are like 5, 6, 7 scrolls long. So these are ones that you have to sit down with, and some of them are a little higher level. The other one I like to talk about a lot, and this one was this is the one that I probably learned off of. This is called Passive Screen, also known as Passive View, as I call it, and that's actually been renamed to Passive View on the article, actually. And Passive View is basically saying it's kind of a view that sits there and doesn't do anything. It's very passive. It just sits there and waits for something to do. And the controller, some people call it the presenter, will actually tell the view, like, hey, here's what I need you to do. And what happens is if there's an interaction, the view basically just passes that responsibility off up to the presenter. So as soon as a button is clicked, it'll say, hey, presenter, on login, click, and then the presenter immediately hops in and takes over. And the view just really does nothing. It's actually pretty dumb at a high level and just sits there at an architecture level just to be presenting information. And all these are kind of wrapped up. These 3 and I think a couple more also as well are all wrapped up in an article called GUI Architectures. And this is quite a large article where Martin Fowler gets into all the different types, from how you can use it with forms and controls, model view controller, application model, model view presenter, which has now been broken out into 2 different patterns, supervising controller and passive view. And then there's also humble view as well. So this is kind of basically the jump off point where you can kind of just come in and be like, oh my goodness, there's a lot. Or if you hear something in this episode that kind of sticks with you, you can kind of go in and take a look at that. Now, quick thing, Martin Fowler is, as you said, is probably on the top of my list of influences for clean architecture and for good design. I have been reading his works for over a decade at this point, and I think it's worth everyone's time to sit down and take a look at his book. And the book that a lot of these things come from is called The Patterns of Enterprise Application Architecture. And I think he refers to it as the PEAA book or something like that. And
yeah, so that's what the acronym stands for, yeah.
Yeah, it's PEAA is what he calls it, and that's the Patterns of Enterprise Application Architecture. And that's a book you can just buy on Amazon. It's a hardcover book and it looks like a textbook. Sometimes reads a little bit like a textbook, but it's just insanely packed with great information.
Really should have done a better job with that acronym, though.
Right, I know.
All right. So starting off these lines of definitions, Donn, the very first thing that I would like to sort of like point out is presentation in general. Now, the reason I'm actually bringing this term is, I mean, obviously it's an English word, and people are going to like, oh, duh.
Duh, Kaushik, come on.
Yeah, but I mean, the point here is anytime you see the word presentation inside one of these terms, it should sort of like have this light bulb flash up in your head. Whenever you see present in the name of anything, think of it as basically any stuff that sort of like relates to presenting content to the UI. So when you say presentation model, presenter, the minute any of these things have like the word present in them, it's nice to actually think of these as always relating to the UI, which means this object, by having the word present in them, does something with your UI. It's key in sort of like dictating how your UI functions. So typically it deals with what is called screen layout, which is basically how the screen is actually laid out in front of you. So what are some examples? What color should this button be? Should it be enabled? Should it be disabled? What text should be showing up? Should you sort of throw up an error on this edit text? Should this certain field be visible? Should the other button not be visible? What position should this field be in? All these things dictate how your screen is going to look. And so anytime the word present comes up, always remember, this is a very good rule of thumb. If you have the word present, that means it has something to do directly with your UI.
That said, I think that's a perfect segue into one of the other terms that's very highly used in a lot of the UI architecture, and that's the word presenter. So that follows perfectly in line with, if you see the word present, pay attention. This is it. This is the presenter. And presenters basically are a loose form of like an MVC. MVC means model view controller. So it's a loose form of a controller, but they typically just deal directly with presentation. And so as a result, what ends up happening is you will follow an MVP, so model view presenter style, but we'll use the controller as a synonym for presenter. So a lot of times you'll be having a discussion with another engineer, and they'll say, well, we're going to use a supervising controller. And remember earlier I said that the MVP pattern, according to Martin Fowler, was split into two different patterns, and that's supervising controller and passive view. And so just as we said here, so anytime you hear presenter, you can kind of think of controller as a synonym for that when we're talking about these patterns. And it's also important to know that presenters are typically just at the form level rather than at the widget level. And this happens to be a very big difference. And so what this means is I'm actually dealing with how things are going to be presented. Now, there are, of course, variations, and some people will argue that, hey, you can control the color of this widget or the color of the screen because you are acting as the presenter for the UI, which is where the presentation is taking place. But for the most part, they're typically dealing with widgets, and so we could talk about that as image views or text views or edit text, and you want to make sure that the hint text is showing up, and you want to make sure that the hint text is set to a correct color, or if you're using the new design material design support library, that using the correct hint text so it pops up and above, or using the ripple effect, that everything is happening as you would prefer to have it happen.
Right. But that still brings up like the question though, Don, like what exactly is the difference between like a presenter and a controller, right? Because both are like super generic terms, and like you can basically do anything and say, well, it satisfies like the term controller or presenter. But a presenter only sort of like works in one direction. That is, the presenter basically helps change the UI. It doesn't necessarily take in the inputs though. That's where a controller comes in. So a controller is an object which basically accepts inputs from the UI. What you would typically do then is sort of pass it off to a presenter, and then the presenter would sort of like send the information back either through the controller or back to the UI and modify that. So that's sort of like the cycle that goes in. One way I like to think about like a controller is it's almost like a sort of superset of your presenter. Many people feel that, well, okay, there's like another extra layer of abstraction. And sometimes if you have like a simple login form, it tends to be overkill. And this is an important point. Sometimes people think of the presenter as a specific implementation of a controller, which means the controller is this superset object which sort of like takes in inputs. So what are some examples? On button clicked, on username entered, on password entered, or on password not entered. These are sort of the inputs that a controller ideally would take in. Now, if your logic turns out to be complex, then you can have like an additional presenter object which this controller would sort of pass that information to. And this goes back to how we initially we talked about about not having God objects and essentially being able to tease out clear and clean functionality into these smaller objects. This is how you basically work with it. You start off with a controller that takes in inputs, modifies your UI, but if the logic starts to turn out to be pretty complex in itself, the UI logic, then all you do is you just pass it off to the presenter, and then the presenter sort of like dictates how the UI should essentially look. Is that like a fair assessment? So I like to think of like the presenter as maybe like either a part of the controller or a specialized form of the controller. So the controller really is like the superset object, which is why Martin Fowler also calls it, like he adds the adjective supervising, which basically means the supervising controller orchestrates all like the UI actions necessary from the user input and also going back to the output, which is the UI screen.
I've seen that definitely happen. Just as per the definition, I've seen it work that way. I've also seen other really complex UIs have, for example, they'll have a controller that manages a bunch of other like supervising controllers, and that and which then in their turn act as basically little presenters in themselves, but kind of have their own little areas. And this is when you get into some real high level, I don't know if you call it high level or low level architecture, where you're basically composing your application, and you're not, one of the popular ways I've seen this done is you actually send down, and I've done this before, is the server sends down form metadata. It says, you know what, the screen is to look like this, and here's the order that everything should lay out in. And then what you end up doing is you read that in as a big chunk of metadata saying, all right, well, there should be an edit text. Here's the validation it should have with this regex, and you can build your form out, and it's all native. And I've seen that done that way, because then you'll actually have a very smart controller that handles that. And then above that, you may have a controller that manages the different screens, because the form metadata says, hey, this is going to be some type of wizard activity, so we need to have four different screens. And it's up to you if you want to implement that as just a simple view pager, or you want to put that in 4 fragments or something like that. So I've seen that implemented both ways. Now, it's kind of confusing. I know that I'm saying you can use it one way as well as use it another way, and that's kind of, unfortunately and fortunately, the way that these things work. What I recommend you do is, if you're getting into this for the first time, just take one simple screen that you're working with and try to pull out a presenter, or try to pull out a controller, whatever you think might be more appropriate at that time. Again, it's a case-by-case basis. See what's going to work, and at that point, and if you don't even really know at that high level, what you may want to do is just pull out a simple presenter where only thing it's going to do is just update the UI. And then you can just get used to that, and then you can start getting into more complex interactions like you explained before, and start getting into the real hardcore controller stuff. Would you agree with that, Kaushik?
Absolutely. That makes perfect sense.
One of the side effects you'll notice from going down this route of creating a clean architecture is that you'll actually have what some people call is a class explosion. And some people get upset about that. Some engineers like to keep the number of files that they have in a project very low. I utilize and lean on the tooling a lot, mainly Android Studio. I follow proper naming patterns that inside of just standard Java, and just use good names inside of all my components to understand where the application is at. And so I may have a lot more files than a typical application would have, but what you'll end up finding is when you hop into a lot of my code bases that I have a clean architecture implemented, and no, I don't have all my applications designed cleanly. I know, bad, but that's just the reality of the situation. But the ones that,
as long as you don't have Hungarian notation in your code, I think.
Yeah. There you go. What was it? Is that really prefix it or suffix it? I forget.
Prefix, like the M prefix, the S prefix, all that.
Yeah. So I think that wraps it up for that definition. The next definition we want to talk about is basically the word model. Now, model is overloaded with qualifiers a lot, and we have domain model, which we could literally have multiple shows just talking about domain model. So domain model, we have presentation model, we have view model. And so firstly, anytime you see the word model, it's just basically an entity that encapsulates state. So we could have, like I said, various different types of them: domain model, presentation model, view model. Again, So domain, presentation, and view, all those words are just qualifiers to the noun model. So, Kaushik, do you want to talk about the first one?
Yeah, for sure. So the very first case is domain model. If you understand the term model, which basically means any simple object that holds state. So if it's a domain model, what does that mean? An easy way to think about it is all like the businessy stuff. So this helps model our perception of like the real world. For example, Donn, you work at Point and they probably have a lot of like these credit card things. So a nice object to think about is like maybe like the credit card object. If you have like a credit card class, that would be a good example of a domain model, because a credit card is very specific to the business of Point, right? It has to be pointed out that ideally, all these are like sort of self-contained POJOs, which basically means they're just plain old Java objects. So if I say domain model, that's essentially what I mean. Does that make sense, Donn?
Yeah, I think it's also important to maybe even further talk about, I mean, like I said, there's a whole book written on the subject. And I worked at Ally Bank years ago, and we implemented an entire system using fully implemented domain models, all the way down to full validations were written in like hibernation kind of stuff. And everything went through before it got to a database or before it came out. Everything went through the domain model, and we were able to write tests against it. It was very, very nice, because we knew that even if we missed something up at the root level, the domain model was basically the source of truth. If it couldn't get through there, or if it's like everything was validated, made sure, like again, credit card object, you have to make sure that the credit card length is proper. You have to make sure that it matches the credit card. There's an algorithm where you can detect if the credit card is correct or not. If it's an actual valid credit card number. I mean, not that it would pass. You could charge on it, but there's a algorithm where you can say, hey, you're missing a digit at the end, it's not going to work. So all that stuff would go into domain models. So I think that's it's very important to note.
So we talked about domain models using our definition or our sort of like rule of thumb about presentation, Donn. What would a presentation model then be?
Okay, yes, good question. The word, present, we're talking about presentation. We're talking about something on the UI. We're talking about what the user sees. So that's what a presentation model, or what some people are calling a view model, is. And it depends on what language or framework you're working in and so forth. It could change, but we'll just stick with presentation model here. And essentially what the presentation model does is it pulls the state and minimal behavior out of the view into a model class. And so this is not a domain model like we talked about before, where we have all this business logic and so forth and validation and so forth. There may be some very minimal stuff in there, but it's just basically the state. Is this, what's the first name that was entered? What was the last name that was entered? This is now part of the presentation side of the fence, meaning that we are now actually working with the presentation. So what it actually does, it coordinates with the different layers of the architecture. It could be the domain layer, it could be a service layer, it could be a facade pattern that you're interfacing with. And it helps minimize the decision making inside the view. I'm sure we've all had, and what I'm talking about here in the view, this is important. When I'm going to maybe reference just the passive view pattern. So when you go back and read this article, you can come back and check the podcast again. The passive view basically treats the activity or the fragment as the view. So not the actual XML file. It treats the activity or the fragment as the view. And so what happens is the presentation model coordinates with the view. That's going to be the activity or fragment, and it helps minimize the decision making in that view. And we may have something where we want to hide a field, or we may want to color something red, we want to show an alert box, and all we do is we check the state of that presentation model. Say, hey, should I show the presentation? Should I show the alert box? If so, okay, I should show it. Okay, what should I show in this alert box? What's the message? I'm going to look inside the presentation model is going to have all of that information in it. It could be as very simple as just a single field object, and it can be as complex as something that has 50 different items in it. Depends on how complex your UI is for that particular screen. Depends on how big that presentation model is going to get. So this is very, very important. We want to let the presentation model dictate all these decisions. We don't want to have to go back and check something else on some other layer of our application. So, for example, we're in the fragment. We want to see if we want to show the enable the button because of all the fields are set correctly. We don't want to have to go up and call some additional service to do that for us. We want to let the presentation model make that decision for, saying, hey, yep, you can go ahead and enable that button because I've already gone out to that other service and checked with that service to make sure it's okay to enable that button for whatever reason.
So let's try to sort of like summarize quickly what we have talked about. Whenever you come across the term presentation, you should have all those sort of like bells light up and say, okay, it means like the UI. It means we're going to be doing view-related stuff. If you talk about the controller, remember, the presentation sort of like does like the output, but you need some object to be able to accept the inputs from your UI that goes through the activity. And what we'll try to do is we'll try to maybe like run through an example, a very simple login example towards the end of the show, and sort of like talk with the supervising controller how we would use this pattern. So the controller is the main object that sort of like accepts inputs. Presenter helps dictate what happens on the UI. And anytime you have the term model use, it's a simple object that just encapsulates a state. So these are like good rules of thumb. Now that you have these like ingrained in your sort of like lexicon, it's easy to go out and then see different patterns and then sort of like make easy decisions as to, well, where should this piece of logic go? Should it go in my presenter? Should it go in my presentation model? And so forth.
I agree with that. It's we'll get into more detail here very shortly. I think, so let's hop in and talk a little bit about the various different patterns that we have been kind of really harping on in this entire episode.
Yep. So the first pattern is essentially the supervising controller. Now, just to give listeners a sort of like idea about how I would actually implement this, let's take a very typical example. Say, like a login behavior. You would have your layout XML with an edit text, say username, an edit text for password. You would have a login button in there. Say we have like we have a login activity where you set the layout inside your content view. You set it to be this layout that we were talking about. Now, personally, I have no aversion towards fragments. I happily use fragments around. So I would, in fact, have a single activity that has multiple fragments, and I would call it the login fragment. But just to make it simpler for our discussion here, let's say that I just have a login activity. So this login activity would basically have your content view, and I would use butter knife to sort of like take in the inputs from the UI. So I would have like a button click listener set up inside this login activity. And here's the interesting part. Within the login activity, I create a controller, and this is what we call in the parlance of a supervising controller. So I would name this my login controller. The button click would basically send the events to the login controller. So I would have a method definition inside my login controller saying on login button clicked with, and I would pass in the parameters for username and password. So this login controller then would internally run logic to check and see if my username was satisfied, if my password was in the right format, for example, if it was the right length, if it had the right amount of special characters and all that good stuff in order to like have this validation go through. So the login controller will perform all that logic, make sure that things are okay. And inside the login controller itself, I would have this interface. Now, most typically people call this interface like the login view or the login screen or something. The way I like to do it is essentially I just have this very simple interface and I name it in a very sort of dumb fashion. So I would call this interface basically I talk to login activity or I talk to login screen. The only sole purpose of having this interface, and when I talk about an interface here, it's essentially a Java interface. So the sole purpose of having this interface is so that I can communicate back to the activity from my login controller without holding a hard reference to an activity object. Because again, the activity object is a very Android specific thing. But inside my login controller, I don't really want anything that's Android specific. I want it to be either related to my business at hand. So in this case, the login behavior is like the businessy kind of logic that we're trying to implement. But what I would do is I would have the login activity implement this interface that I have within my login controller. And the reason I would do that is because in the end, the login controller, as we mentioned before, takes in inputs, but it needs to send that input or control the UI back in some fashion. So the interface inside my login controller basically maps to that. So the interface would have methods like show a spinner, because that basically means, well, okay, we're going to start like a network call. I would say, no, the password was incorrect. So set password error, or throw password error, or throw username already taken error. And these methods, so these are the precise method names that I would have within this interface inside my controller. And based on the logic that I run on the username and password, it would send the inputs back to the activity via this interface. The whole advantage, again, of having this interface is because when I'm actually testing, I don't have anything related to the Android framework. These tests are JVM tests, and they would run like super fast, because I can just say, okay, assuming I have this object that implements this interface. In the real world, would be our activity, as I mentioned. But in my testing, I could just have like this mock interface saying, okay, assuming this object passes you this specific username and this password. Okay, make sure you call password error set on this field, right? So that's basically, again, this is more easily sort of like demonstrated with a precise example. And hopefully at some point I'll try to like open source like an example where I demonstrate this whole controller interface. Also, a friend of the show, Matt Logan, has this blog post, and again, we posted this blog post in as a sort of Easter egg in one of our in our very first episode. He talks about the importance of using this interface, like this whole concept of why I'm using an interface versus just directly sending in my activity and holding a reference, and why it makes it easy for testing. He explains it very well in this blog post, which we'll add a link to, so you listeners can sort of read that and again get much better understanding of why the advantages of using an interface instead of like just holding a reference directly to the activity. But it basically boils down to making testing very easy, and it allows you to sort of iterate UI logic, which would otherwise be very difficult, because if you didn't have this whole Pojo approach to your UI, like if you didn't have the supervising controller and it was all performed directly in the activity, then I would have to have like UI tests or like espresso tests, and these run on the device and they're slow and they're very hard, as we know. But if it was all in the JVM, then all I can do is I can just mock out the Android-y parts. So like this, essentially this interface it deals with like the Android-y parts, like setting the edit text, applying an error on this. So I can just presume all of those to work and make sure that they're being called in the correct order, because it goes back to what I was saying initially. In the end, what we really care about, and this is one of the goals of like the whole thing, I don't want to test if text views work. If I set a certain string or a text on a text view, it's going to work. I mean, because Google's done a good job with making sure text views work in the right fashion. All I care is the right text is going to the text view, and pushing that into like this controller or a supervising controller object makes it easy, so that I can simply test for the right string going in the output, and then all is well. I don't sometimes, and these are certain situations where I wouldn't even care about testing the UI, because I know I'm sending in the right string or the right text. What are your thoughts on that, Don?
That's the supervising controller is one that I've been warming up to as I found the need to introduce more complexity and handle more complexity inside of the architectures that I'm building. And to tell you the truth, the one that I'm actually the most familiar with is actually also called passive view, and sometimes it's called dumb view. And it's very, very similar to how you explain supervising controller works. But the big main difference in the way that passive view works is that all of the view update behavior is in the controller/presenter. And so I'm just going to call it presenter here, is inside of the presenter or controller. And this includes like even the simplest use cases. The thought process is that the view should not make any decisions at all. It has no intelligence at all. It needs to delegate all of its responsibility to a higher order. And what this allows you to do is really remove all of the logic and all of the decision making from that view. So you can actually, the main point for me was I could test everything. And this enabled me to make sure that the views were being shown correctly, the colors were updating, and so forth. So what this ends up doing, though, is you will notice if you try to go down this route, it results in an insane amount of extra programming. But it does mean that all of it is testable. So that's kind of the trade-off that you have to have. Now, it also does increase some maintenance time. So now, this is also a trade-off you have to consider. You need to go update something. Well, now instead of just going into the activity or fragment, you need to go into your interface, which is what the passive view does. Very similar to supervising controller. It has an interface. So you call it the I talk to something controller or I talk to something presenter. And you need to actually at that point make changes there, make changes in your controller, make changes in the activity so you could implement these various different things. It could take you a lot of extra time to do that. But again, it does expose the ability for you to test it, which previously you may have not had before. So the choice between if you need to go with passive view or supervising controller depends on what kind of data binding support you need to have and basically what you're okay with leaving untested. And that's just a case-by-case basis for you. Now, what usually ends up happening is when you have the view reduced to that dumb slave that you're basically using, you run little risk by not testing the view. Now, because you've accessed all that code, I mean, not saying it's not risky at all, but the risk is a little bit less if you just kind of left it inside of the activity. And in short, I usually try to test anything that I have a interface method for. I want to make sure that it's wrapped in tests. Now, one of the benefits of this, again, it's going to be on the JVM. You could test it. You can use tools like Mockito to really mock out other dependencies. Maybe your presenter is actually going to talk to another layer of your application. That layer needs to go out to the web, needs to go to the database, needs to make a network call, do something that takes time, asynchronous, whatever. What you can do is you can use Mockito at that point in time, return some mocks, return some stubs, and actually test all the various different implementations to make sure that your presenter is doing exactly what you'd like to do. Again, it's up to you to decide which one you'd like to use, but I think that passive view or supervising controller, you're going to have a great time either implementing it, learning about it, and also you're going to have a lot of confidence at the end of the day with the amount of tests that you can write.
And the final pattern that he talks in detail is the presentation model. And again, we talked in detail about like the presentation model before, so we're not going to like dive into too much details. These are three important sort of like fundamental patterns that he brings in. Now, many of the sources or the references that we're going to like point in don't necessarily point directly to Martin Fowler because, again, these are not Android specific, but like we think it's important to sort of like understand these core concepts because it lays a very good foundation for you to be able to evolve your own framework. All right, so we should quickly now give our listeners just maybe like the references so that if they want to do more in-depth reading and get a better understanding of these patterns, they have something to go with.
Definitely. I think the first one that we should probably talk about is I'm not going to read the URLs because reading URLs through a podcast just sounds really awkward. But I will reference the actual, just the root site, and then the actual links will be in the show notes if you're interested. So you could view the show notes on your device or go to the website. The first one we should talk about is Martin Fowler. We've talked about him a ton in the previous sections. His website is martinfowler.com. You can go there, just, print out his whole website and bring it on vacation, and you'll be content.
Right. Another good reference I've seen is basically this blog post from the Willow Tree folks. So the website is willowtreeapps.com, and they talk about the MVVM on Android approach, like basically what you need to know. The reason I like this article is because it's a nice and abridged form with definitions, and it sort of like, again, allows you to sort of quickly get an understanding of these terms.
Number 3 that we should bring up here is a great article from an iOS developer on the same subject. And the title of the post is like Model View Model, so MVVM is it's called for iOS. And now again, this is iOS, it's not Android, but we do have to realize that this is also an embedded system. This is iOS. A lot of the iOS developers encounter a lot of the same problems that we do. And at a high level, if you look at Martin Fowler's work, you'll see that he does a lot of stuff in Rails, and he does a lot of stuff in Java and now Go. So a lot of these patterns cross the boundaries. And so this is just another look into the model view model. And that's going to be at thanlax.com. And just check out the show notes for it. I'll probably get it wrong.
Speaking about iOS, there's another article from iOS, and this has a really nice and catchy name. It's called the Viper architecture. We'll add link again to the show notes for this specifically, but there's this famous series that's called the objc.io. So Objective-C.io is like this sort of like magazine online-y kind of format. And one of the articles, they actually talk about this Viper architecture in detail. Again, these are very generic concepts, so they apply to us and it's very pertinent. So definitely you can have a look. I believe Richa Khandelwal, I think she's sort of like adapted the Viper architecture pattern in Android and given a presentation. That's also a fantastic link. People should definitely read that.
The next article we're going to talk about is by a developer by the name of Fernando Sejas. And Fernando, I'm sorry if I butchered your name. I apologize. But this article is great because it provides a lot of diagrams, really helpful diagrams to help you understand how you can architect Android the clean way, hopefully. And he talks about from various different things, from entities, use cases, presenters, UIs, business rules, also in this case called interactors, various different parts of domain logic. He has some video in there to show kind of the test application that he's working with. Various different, swim lane diagrams to show the different boundaries between the layers, the layered architecture, very similar to what I talked about earlier, how the MVP, model view presenter pattern works, how the domain layer works, data, etc., error handling. So it's a really good place to get a good jump off point if you're looking to hop in to learn a little bit more about architecting Android in a clean fashion.
Yeah, makes sense. Fernando is an amazing guy. I had the pleasure of meeting him this I/O. And he's a super cool guy. He works over at SoundCloud. And as you folks know, Matthias and like some of the engineers there are like some of the early adopters of RxJava in Android. Super, super smart folks. And this article was one of the early ones with this whole clean architecture. And I love this article. Speaking about smart developers, there's also another article, and this is by Antonio Leva. He has like a nice and simple explanation of like the MVP for Android, and this is again a very famous, it's been doing the rounds in Reddit. This is also a very good article where he talks about like how you can organize like the presentation layer via this whole MVP revolution that seems to be going. So that's a great article as well. So it is time for the awesome picks for the week. Don, how about you go first?
Yeah, I can go first, definitely. The first one is actually, I'm going to throw the ball right back in your court and reference you gave a talk, Kaushik. I don't know, how long ago? Was it last month or something?
I guess it was last month.
Yeah.
It was last month. It was like in the SF Android meetup here.
Yeah, so you gave a talk at the SF Android meetup. The guys at New Circle graciously recorded it and published it on YouTube. And the talk is your introduction to RxJava. I think the talk is awesome. It's phenomenal. Anyone who's looking to get into RxJava should really, really take a look at it. The next one is, and actually, let me give you, everybody, the listeners, an idea, especially if you're working in a team of two or more. Sit down and have your manager, somebody, get them to buy you pizza for lunch and watch the talk at lunch. I did this for many teams that I've managed over the years. We'll just have once a week, we would basically bring in pizza or sandwiches or something like that, and we would watch some type of screencast for the hour and learn something new as a team and then discuss it afterwards. It was a great team building and a great chance for everyone to kind of sharpen up on their skills. So check out Kaushik's talk that way. It'd be great. The next one is a link by Dan Liu, and it's the link that talks about loading data from multiple sources using RxJava. And this is when you may need to, Dan and I talked about this months ago, where we need to load data from the network, but I also need to check to see if it's located locally in a cached environment. And then I need it to automatically pull from whichever one returns first, and then perhaps even go out and continue making the network call if that one didn't return, so I can update the data and make sure it's up to date. So this kind of just helps pulling data and working with a caching mechanism a little bit better if you're using RxJava. Two more links here. One is called Store.io. Store.io is a new library to help you work with SQLite databases. It kind of gives you a nice chainable set of operations to work with SQLite databases. For example, you could have a list of tweets that were in your database, and then you could work with this basically Store.io, and you say, .get list of objects of this class with this query, and you kind of chain the query together with this table where this author with these arguments build it, and then you can execute it as blocking, etc., and so forth. So it makes working with SQLite database a little more interesting. So if you're working with databases, check that out. And then the last link that I have is actually by Martin Fowler. And this is something that I think a lot of people need to understand if you're getting into testing and you're doing development testing. You need to understand what the difference between a mock object is and a stub is. And those are two different things. Martin Fowler explains it very clearly in this article. Mocks aren't stubs. So check it out. What about you, Kaushik? What do you got?
All right. So I have only one recommendation, but I have many supporting links. My awesome pick for this week is the Facebook library Rebound. Now, Rebound is an animation library that sort of models these spring dynamics and gives a more natural feeling to your animations. I've actually compiled videos that point to precise examples. So make sure you check the show notes. I'll add 4 YouTube links that sort of like give you a demonstration of some of the animations you can do with Rebound. In addition, there are 2 blog posts that I want to point listeners to. First is by Matt Ware, and he has this blog post where he uses the Rebound library when he worked at Evernote, and he talks about how he sort of like had this effect applied to one of the features, like I think they call it Skittle. So that's a feature that he uses this animation, and he talks about the implementation details. I thought that was a fantastic post. In addition, Will Bailey, who's actually the creator of the Rebound library from Facebook, he has a gist over at GitHub, and it's called the origami activity. So this is nice just because it demonstrates how you can actually use the Rebound library. He also has a blog post over at code.facebook.com where he talks about Rebound under the hood. So basically building and open sourcing the library and the thought process behind that. So that brings us to the end of this episode. You can find the show notes for this episode as always on fragmentedpodcast.com/episodes/11. If you have feedback or suggestions for us, please send in your comments, your suggestions, send all of them to our Twitter account that we have set up, and that is FragmentedCast. So FragmentedCast is the Twitter handle. Keep sending in your suggestions to that Twitter handle, and Donn and I will get back to you. If people want to reach out to you, Donn, where's the best place?
The best place to get a hold of me is on Twitter, and that's at Donn Felker, DONNFELKER. That's with 2 N's, or you can go to my website at donnfelker.com.
Excellent. My Twitter handle is Kaushik Gopal, KAUSHIKGOPAL, and my website is kaush.co. Thank you so much for listening, and we will catch you folks in the next episode.